Hello, my name is Michael Hoover, and I am the Program Coordinator for the All Hazards Analysis Framework as part of the Infrastructure Assurance and Analysis Division at Idaho National Laboratory. I am the technical lead for this project, and today I am joined by my colleague, Logan Browning.
Hello, I'm Logan Browning, and I am a digital twin visualization scientist for the Digital Engineering Department at Idaho National Laboratory. I'm the program lead for a team of 5 interdisciplinary specialists who contribute to digital twins for critical infrastructure visualizations.
Today, we are demonstrating the prototype results of the collaboration between our 2 divisions at Idaho National Laboratory regarding the mixed reality visualizations of critical infrastructure, software bill of materials, and cyber vulnerabilities found in critical infrastructure. As we identify cyber vulnerabilities and SBOMs found in critical infrastructure, we can simulate the potential physical disruptions that could occur if those vulnerabilities are exploited. This collaboration parallels other efforts at Idaho National Laboratory, like the Control Environment Lab resource, in the modeling of the control systems of critical infrastructure. As we develop our capabilities of interacting with critical infrastructure in a mixed reality setting, we can help stakeholders understand, through visualization, how real-world infrastructure assets and their dependencies are affected by industrial control system vulnerabilities. Both Logan and I will be wearing a mixed reality headset for this demonstration. Viewers of this demonstration will see what Logan sees while wearing his mixed reality headset. Today's demonstration of the mixed reality visualization will include infrastructure and software bill of material data that could be found in the United States National Capital Region, but for security purposes will not display any real SBOM vulnerability data.
We are using the Microsoft HoloLens 2 that uses mixed reality technology to holographically represent 3D models in your physical environment. To clarify mixed reality from virtual or augmented reality, virtual reality surrounds you in a completely immersive environment. Augmented reality generally uses your phone to represent 3D objects in a desired location, while mixed reality blends elements of both virtual and augmented reality to incorporate multiplayer, real-time data interactions with the visualized data.
On screen, you now see the geospatial tabletop representation of the National Capital Region. We will now zoom in to better visualize infrastructure assets and their dependencies. The assets and dependencies rendered on the geospatial interface relate to real-world critical infrastructure assets from the All Hazards Analysis Infrastructure dataset. The All Hazards Analysis Framework is an infrastructure dependency knowledge management system that models how the 16 sectors of critical infrastructure are functionally interdependent. The representation of the data has an asset symbology that is generalized, and dependency types are represented by different colored lines. The dependency lines are point-to-point references and do not represent the actual path of the dependency. As we develop the infrastructure and dependency datasets, we can effectively model how disruptions to critical assets can affect a variety of other downstream assets. Using mixed reality, we can more fully understand software bill of materials that are found in critical infrastructure assets. There is value in visualizing software bill of materials in mixed reality because a single infrastructure asset could have multiple SBOMs, and a single SBOM could be applied in multiple assets across different infrastructure sectors. Users of the mixed reality visualization can see these connections either from a top-down or bottom-up approach, depending on the scenario. Through identification of critical cyber vulnerabilities in SBOMs and their operational functions in an infrastructure asset, we can simulate the potential physical disruptions that could occur if the vulnerabilities are exploited. Mixed reality is indispensable for visualizing and communicating impact across abstract dependency concepts. Furthermore, by doing so in mixed reality, we can share a common visualization of that data for multiple people across any distance with remote video conferencing technology and the ability for multiple headset users to join in the same multiplayer visualization interaction. From this simulation, we can see the disruptions to National Capital Region infrastructure assets that could occur from a cyber vulnerability being applied to the water treatment plant we viewed earlier. As additional capabilities in the All Hazards Analysis Framework progress, the simultaneous development and use of mixed reality will enable users to intuitively explore and better understand the dependencies that exist between critical infrastructure, software bill of materials, and vulnerability data. What we have demonstrated today has been the result of 5 months of prototype development. We are excited for the advancements that could be made with full funding support. As a user and the coordinator of the All Hazards Analysis Framework, I'm excited for the integration of mixed reality capabilities into the application, as it provides more opportunities to collaborate on a shared data visualization and analytics platform. I believe users would benefit when working with renders of specific infrastructure assets and their subcomponents contained within, as well as other models found in the All Hazards Analysis Framework, like the National Critical Functions and Infrastructure Data Taxonomy models.
With more funding, we can provide people across the nation with headsets that will allow for remote, real-time collaboration and promote an accessible instruction toolkit across the organizations. Additional critical infrastructure asset locations, similar to the ones you saw us present on the National Capital Region, could be developed for mixed reality application so that All Hazards Analysis Framework users, asset owners, and other stakeholders would be able to visualize the asset's unique infrastructure data and participate in training that focuses on distinct circumstances associated with the chosen asset and its dependencies.
In addition, continued collaboration on mixed reality would ultimately allow for all analytical capabilities that exist in the web application version of the All Hazards Analysis Framework to also be available in a mixed reality context. This would be particularly useful as we begin to aggregate knowledge on SBOMs and their dependencies, as well as vulnerability information found in CISA ICS security advisories in both the Common Security Advisory Framework and human readable formats. With vulnerability data available and associated with infrastructure asset and its SBOMs, a mixed reality user in the All Hazards Analysis Framework will be able to make better decisions on how vulnerabilities affect our nation's critical infrastructure based on a better visual understanding of data interdependencies.
Thank you for your time.